uh, the next section we're going to talk about is function operations. We talked about functions. Now we're going to talk about some of the operations we do with them. So first, we're going to talk about uh, the four basic operations given two functions, f of x and g of x. There's not going to be any surprises here. It's mostly just notation. So with addition, you simply just add the functions together. With subtraction, subtract it. Multiplication, multiply. And then division, we divide. And just use your techniques for combining like terms. That's basically it. So if we pick some examples, let's say I have f of x equals x squared minus 2x, and g of x equals x minus 2. So let's say we do addition first. So f of x plus g of x. Plug those guys in. So we have x squared minus 2x plus x minus 2. Combine like terms. So we get x squared. Then we have negative 2x and x, which is negative x. And then minus 2. Okay, using the same functions, except with subtraction. That's just going to be f of x minus g of x. So that's going to be x squared minus 2x minus x minus 2. Let's go ahead and distribute the negative sign before we combine like terms on the second one. So it's negative x plus 2. So when we combine like terms, we get x squared minus 3x plus 2. Okay. Multiplication. It's going to be x squared minus 2x times x minus 2. Going to distribute here. We get x to the third minus 2x squared minus 2x squared plus 4x. Combine like terms. We get x to the third minus 4x squared plus 4x. And then last but not least, division. F of x divided by g of x. That's going to be x squared minus 2x divided by x minus 2. Okay, we do have a way we can factor the top part. And then you can see that the x minus 2's cancel. And all I'm left with is x. Now, sometimes they don't always simplify, but this one did. Okay, now, there's our four basic operations. We're going to introduce a new operation. The new operation is called composition. Okay, the way it's defined, first off, the notation looks like this. It's a little open circle. Okay, composition is defined by f of g of x. Okay, so I told you that with the function, anything in the parentheses you plug in to the function. Well, now we're plugging in a whole entire function into another function. Okay, if I have, say, g composed of f, it goes the other way. G of f of x. Important thing to point out here. F of g of x is not the same as g of f of x. So they are not commutative. It is not a commutative property. For all cases. I can always come up with a case where it works, and we'll talk more about that later. But for all cases, it is not commutative. Okay, so let's say I have f of x equals 2x minus 1, and g of x is, say, 4 over x minus 1. If I want to find f composed of g, that is f of g of x. So that means in f of x, I'm plugging in g of x. So I'll do that in one step. Then in the next step, I'm going to actually plug in what g of x is, which is 4 over x minus 1. So that is 8 over x minus 1 minus 1. If I do it the other way, g composed of f, that's g of f of x. I'm going to take g of x, which is 4 over x minus 1, and plug in f of x in for x. And then f of x is 2x minus 1. So we have 4 over 2x minus 2, which will simplify to 2 over x minus 1. Okay? Now let's talk about domain of these guys. Now, when we consider the domain of a composition function, we have to consider the domains of the original functions as well. So let's say that I have f of x is equal to 2 over x minus 3. And I have g of x is equal to the square root of x plus 4. Okay? Well, we have to point out here that because of f of x, that bottom part cannot equal 0, so x cannot equal 3. And then over here I need to point out, because of g of x, what's in the under the square root always has to be greater than or equal to 0, so x has to be always greater than or equal to negative 4. Now, if I find f composed of g and I need to describe its domain, I need to consider both of those restrictions as well as whatever restrictions come along with the composition. So if I do this, I will have 2 over g of x minus 3, which is 2 over the square root of x plus 4 minus 3. Now, because of this, you can see that the square root of x plus 4 minus 3 cannot equal 0. So I need to find that restriction as well. So x plus 4 cannot equal 3. Square both sides. X plus 4 cannot equal 9. And that gives me x cannot equal 5. So I have 3 different restrictions here. It's always greater than negative 4. It cannot equal 3. And it cannot equal 5. So when I describe my domain of f composed of g, it's always greater than negative 4. It messes up at 3. Then it goes up and messes up at 5. And then it goes on to infinity. So there's my domain. We'll stop there.